Good morning, everybody. Welcome to the third New Wave webinar, this time focusing on fast pyrolysis and on the opportunities deriving from it. I'm Giulio Poggiaroni from ETA Florence Renewable Energies, and I will support the moderation of this webinar. So a few housekeeping rules before we dive deep into the topic of today's. Please use the Q&A tab to post your questions to the speakers that we will be very happy to answer after each presentation. And the chat tab will be used to communicate important information and share links. You already find in the chat box the link to the New Wave website where you can discover more about the value chains that we are experimenting in the project with the help of the partners. The webinar is recorded and the video will be available on the New Wave website as well as with the download of the presentations that you will see today. So enough from my side. I give the floor to Bert van der Beld, who's the coordinator of the New Wave project, to introduce the webinar and our speakers.
Thank you, Giulio. Good day, everyone. And also from my side, welcome to this webinar. And I'm also very happy to see that so many people showed interest in this event. My name, as mentioned, is Bert van der Beld. I'm the director of BTG. And together with my colleague, Hans Heres, we are coordinating the New Wave project, a project funded under the Horizon Europe Framework Program. Very briefly, the objective of the New Wave project is the development of manufacturing lines using fast pyrolysis, bio-oil or fractions thereof as a sustainable raw material. And examples are, for instance, polyols for polyurethane, phenol formaldehyde resins to be used in wood construction or in insulation material, and formulations for preserving wood. While obviously, it's then very important to have the raw materials available. And today's webinar focuses on the production of fast pyrolysis bio-oil and its fractions like pyrolytic sugar and lignin. Therefore, I'm very happy to have two excellent speakers on this topic. Pontus Friberg of Pyrocell will share his experience on the commercial production of fast pyrolysis oil, and Gerhard Muggen of BTG Bioliquids will update us on the next steps concerning the implementation of pyrolysis oil fractionation. I think that's sufficient for the introduction now, and I would like to introduce the first speaker, and that's Mr. Pontus Friberg. He is the chairman of the board of Pyrocell, and he has also been involved in the development and operation of the Pyrocell plant in Sweden from the beginning. And today he will share his experience with fast pyrolysis. So please, Pontus, the floor is yours.
Thank you. Let's see, I hope it works. Yes. Do you see my screen?
Yes, can you maximize it?
Yes.
Yes.
Great.
Yeah, there it is.
Perfect.
Good morning, everybody. Yes, my name is Pontus Friberg, and I'm the chairman of the board of Pyrocell. And I've been asked to tell you a little about what the Pyrocell is and what we are doing. And as said in the beginning here, we run a commercial production of pyrolysis oil since 2021. So it's almost 3.5 years now since we started the operations. And I was thinking of the following points of presentation, a little about the plant itself in brief, and looking back also from the beginning and where we are today regarding our experiences and the results year to date. And finally, also about the position we have as a company, the opportunities we see, and also the needs we see for development, and especially then refining the oil. That's more or less what I would like to talk about. The Pyrocell plant itself looks like as the picture you see in front of you, and it's very closely built together with the sawmill, and in the background also pulp and paper mill, and as well a heating plant. And ownership structure regarding Pyrocell is that it's jointly owned by Setra. Setra Group is a wood industry company, Swedish owned, and also Preem, which is a refinery and a group of biofuels producing company here is as well in Sweden. You can read more about Setra Group and Preem on their homepages that I pointed out there in blue. The technology that we are using at the plant is fast pyrolysis technology, and that is provided by BTG, and we will listen soon to Gerhard, and he can talk more about that in case there is time for it. But that is for sure what we are using as technology. Feedstock is quite unique. We use only the residual product sawdust, and that comes directly on conveyor belts from the sawmill, and we use only pine, or in Latin Pinus sylvestris. There's only one species that we need and have tried since the start of operations 2021, with successful results, I must say. The target quantity of the plant is roughly 25,000 tons, and we are soon there now. It's pretty close. And we run the mill or the plant in a continuous operation. It's a shift work, 24/7, and it's 5 shifts, and we run it's 12-hour shifts. And we have done that also since the very beginning. All in all, including management, we are 14 people. And we have 2 income streams, of course. It is the fast pyrolysis bio-oil. That is the key product and the core business. And the product and the process is certified since 2023, according to ISCC, both EU and plus. And we sell the oil to the Preem refinery at the Swedish west coast in Lysekil. The other income stream we have, that is steam. And we use steam for drying the sawdust, as the sawdust that is bought from the sawmill is wet. It's around 52-55% moisture content. So we need the steam for taking it down to around 3% moisture content. But we also get some excess steam, and we sell that to the sawmill, the nearby located sawmill that belongs to Setra. So those are the 2 main income streams currently. Perhaps you have understood by now that the core business for us is to produce this raw material, pyrolysis oil, for Preem and their refinery. So the core business is biofuels for the transport sector. And that is what they do also at the Preem side on the Swedish west coast at the refinery. The plant itself is it's nicely located, and it's quite unique as regards to the content and the degree of the integration. It is integrated, as said, with a sawmill, so there is no transportation on trucks between the sawmill and the plant. It's more like just a conveyor belt. And we also have integration regarding steam, both with the sawmill and with the heating plant. The heating plant you see in the background in green. And also, of course, most important perhaps is the supply chain from the Swedish forest down to the refinery at Preem. We have a lovely supply chain, and all transportation from the plant nearby storage tank is done by rail. So it's a rail transport from Gävle, where the plant is located, down to the refinery on the Swedish west coast. Down there is a kind of co-processing via an FCC, a catalytic cracker. And so it's a blend with other types of fuel. That is what's done down there at the refinery. Yeah. Experiences, yeah. On the right-hand side, you see the value chain. I'm not going to dig into that into details at all. I would like to more focus on how we follow up the operation as regards safety and health, quality and yield, performance and compliance, and economy. I will tell you a few words about that on the next slide. And this is year to date where we are after these 3.5 years of operation. And so important, and it's worth mentioning many times about safety and health. Knock on wood, but so far we have no incidents that have resulted in injury or with absence. We count LTAs and lost time accidents, and so far we haven't had any. And also within the organization, which healthy so far, no sick leave, more or less, in practice, nothing, short or long. That's good news. As regards quality and yield, we are on specification regarding the oil quality and sawdust, and who tells us what the specification is? Of course, that's the customer. In this case, it is Preem Refinery. So far we are on specification, and that's super important. No claims whatsoever. And as we sell energy, the energy yield is also super important. And of course, when we bought this plant, we had expectations regarding the energy yield, but it seems that it's much better than the preliminary calculations. So it's far above what we expected, and that's good news as we sell, as I said, energy. We're not selling tons. It's megawatt hours we are selling. Performance then, that has been a journey, and we have learned a lot since 2021. But right now we are on track, and we are also in line or even above the figures that we got from the technology provider. So that's been the focus area since we started the operations. I mean, productivity is important, how many tons you produce per hour, but it's even more important that we know how many percent on stream we are. And that is what we see now. This is what makes the money also in the end. Mentioned before about certification, and that is a must, and we cannot sell the oil without having the ISCC EU and Plus certificate, and we obtained that in April 2023, and it's just a few months ago renewed, so that's good. Finally, a little about economy. We did this for us huge investment, but so far we haven't been in a position that we have to add any capex, and that's good. I mean, financing or funding this kind of operations is always so challenging, but we have what we have, and it's doing a great job. The plant is working excellent. And as regard OPEX, always a question mark until you have been running an operation for a couple of years, but right now it's very predictable and the operations are stable. So our owners are quite happy. They'll never be 100% happy, of course, with the results, but we are happy and we are satisfied with the EBIT and EBITDA and the margin as such. And this during a period since 2021, we have seen sharp increases in feedstock prices. And when I talk in feedstock, I mean this sawdust. So for us, as a rather small company, cash flow is, of course, what is more important than the EBIT. So EBITDA is highest priority. Finally, our position, what have we done? Where are we? What do we see as opportunities, and where are the needs? We have quite unique value chain, and the value chain that starts in the Swedish forest and down to the tank in the car via Preem Refinery. We have access to the sawdust. We have a factory, the Pyrolysis plant factory. We have a green product, and we also have the customer within the company, Preem, and the refinery. And that is the core business. And according to calculations done together with Preem, we see that we reduce the CO2 emissions by up to 97% compared to their fossil alternative. And that is really good. But also we see now after a couple of years that there is need for upgrading of the oil. And you could do that in different ways. And I think Gerhard will soon mention one of the alternatives, how to upgrade or refine the oil. But ideally, in the value chain between Cetra, Pyrocell, and Prim would be to come as close as we can to a green crude, of course. And we need to reduce the content of metals, oxygen, water, that is for sure. Regarding how that upgrading should be done, you can discuss, but we are of the opinion that we should, as long as it is possible, try to use the existing infrastructure in the value chain. That means low capex as well, and that is key. Also, if we could come as close as we can to kind of green crude, it would absolutely help us to increase the throughput of oil in the refinery at Prim, and also in the long run, strengthen the competitiveness of the oil that we are producing. And I mean, we have to increase the value of the oil also, as the feedstock prices, meaning biomass, are constantly increasing in our country, and I believe in Scandinavia. So we see that if we can refine or upgrade the oil, we can increase the value, and by that also, if we can improve the properties of the oil, that opens new market opportunities. And what we see in front of us is, for instance, the aviation fuel, of course, the SAF. And also we see many applications with the chemistry and metallurgy, and that's ongoing and rather promising, I would say. And in the end, also, you always have the alternative of heating, even though that is not the #1 priority for us. Yeah, that's my last slide, and I thank you for giving me the opportunity to talk a little about Pyrocell. Thank you.
Thanks a lot, Pontus. Very interesting presentation. Also very good to hear that you're on track with productivity and availability, and even the economics are according expectation. Yeah. I'm just looking for questions, not sure whether I can see all the questions, but one question is on do you have clogging problems in the reactor due to the use of wood sawdust?
We have had in the beginning, but right now, nowadays, we don't have any big problems with that. No longer. No. Thank you.
Can you see any other questions, Giulio, by the way?
Yes, there are a few others. What is the sawdust biochar utilization? What Pyrocell does with biochar management?
Can you elaborate a little about the question?
Oh yeah, just read the question. So what do you do with the biochar?
Okay, the biochar is burnt. If that is the question, we burn it, and okay. That's so we get heat from it.
Okay, so you use it as a fuel to run your activities. Yeah. Okay, very clear.
So non-condensable gases and biochar, that is burnt.
Okay.
It's burnt within the process. It's not in a separate installation. It's part of the overall process.
Yeah.
Okay. Then there is another one. What are the environmental impacts of fast pyrolysis compared to traditional fossil fuel processing? That's a general.
I think the presentation gave a kind of answer to that, and it's calculated together with Prim and others also that the emissions are reduced heavily, and as I said, up to 95-97% CO2 reduction as regards emissions. So it's a huge impact.
Okay.
Otherwise, I mean, noise or so is not an issue any longer. Some people are afraid of that, and also the smell, but we haven't had any complaints about noise or smell.
Okay. There's another one. What about the oil production? What is the yield of the oil obtained?
Excuse me?
What is the yield of the oil obtained?
I think that Gerhard can talk about that or answer, because I don't want to comment too much in detail regarding our operations, but I think there is well described from BTG's side. Yeah.
Okay. Okay, then there is another question about the properties of the bio oil obtained, but probably this is also being addressed by Gerhard.
Yeah.
Is the steam product also coming from the combustion of non-condensable gas and char?
Yeah.
Okay. Great.
May I ask one question?
Yeah.
Pontus, you mentioned that your sawdust had a moisture content of around 50%.
Yeah.
But you generate internally sufficient energy to dry it to the 3%, so you don't need any external fuel?
That's true. That's true.
Okay, that's very good.
Okay, there was another question about probably referencing the bibliography for the CO2 reduction calculation. Probably, I don't know if you have it right under your hand, but maybe we can make it available later on. Also posting on the website. But I mean, there is plenty of insights on that. Bert, if you agree, we could move to the next presentation and then continue with the questions that are, some questions are still popping up, but don't worry, we have time and we will answer it at the end of the webinar.
Okay, thank you.
We will do. Once again, Pontus, thank you for this presentation. Very nice, very informative.
You are welcome.
We will now continue with the next speaker, and that's Gerhard Muggen. Gerhard has been the managing director of BTG Bioliquids since 2008, so almost from the beginning. Amongst others, he was responsible for the implementation of the Empiro commercial demonstration plant and also for the delivery of the similar production plants to Sweden and Finland. You just heard about that. I think today he will share his ideas on fast pyrolysis and also the way forward with respect to pyrolysis or fractionation. So please, Gerhard, the floor is yours.
Thank you, Bert. Can everyone see my screen?
Yep.
Yep, perfect. For some reason, my screen is not working. Try it again.
We see it.
There we are. No, better, yeah. Sorry. In my presentation, I have several topics to discuss with you. First of all, a short introduction of BTG Bioliquids, something about the value and logistic chain, something about the modularization, because we believe it's very important to modularize and to standardize our technology. We have our motto, scaling by numbers, an overview of the different applications of the fast pyrolysis bio-oil, biorefinery 20, and I will end with a summary. Yeah, who we are? We are a technology provider, and we consider ourselves product leader in the field of fast pyrolysis technology, making the fast pyrolysis technology, but also the commercial deployment of the fast pyrolysis technology. Second bullet, yeah, it is obvious we only use second generation biomass, so we're not competing with the food chain. The third bullet. What we are seeing in the market is very important not to only concentrate on the fast pyrolysis technology itself, but also to enable projects. So it means that we are bringing together different parties of the value chain and shaping our own project rather than waiting for companies doing it for us. So yes, of course, we will serve the biomass companies, and yes, we will serve the oil companies, but in parallel, we also develop our own projects, which I'll explain later in my presentation. Last bullet, yes, highly standardized and modular design. Our motto is scaling by numbers. What we are doing is we are coupling the biomass world with the, sorry. I have some issues, guys, with my screen. I don't know what's happened. Sorry. Value logistic chains. We are coupling the biomass world with the petrochemical world. The biomass world is typically quite far from, let's say, the industry. And we believe it's very important that you're connecting these worlds with a liquid. The advantage of a liquid is you can transport it and you can store it and use it anytime you like. That's a very important advantage of a liquid. Oh my goodness. My computer stops every time. Sorry for this. We checked it before, but modularization. Why it's important to modularize? If you look to the market, you can see that a lump sum turnkey projects stick build result in a very high risk, long time on site, weather risks, and lots of site engineering construction, leading to high capex due to the risk reservation in the price. Especially in the US, you see enormous prices on lump sum EPC projects. There are, of course, considerable risks, but when using modularization, you're really reducing the risks, which is a big advantage. Because what you're doing is you're lowering your risk due to building of modules in a factory environment rather than building on site. Short delivery times, because the building of the modules and the site preparation can go in parallel. Time on site is very short. Pontus didn't mention it in his presentation, of course, but if you look to the erection of the plant, erection of the modules, we can do it within 2 weeks. That's been demonstrated first in Pyro, then at the GFN in Finland, and also at Pyrocell in Sweden. Third bullet, lower costs due to the high degree of standardization. So the typical scenario in the petrochemical world is larger scale. We strongly believe that if you standardize properly, that you can easily reduce the costs rather than building huge equipment. Another one big advantage is if you bring the let's say the pyrolysis plant to the biomass, the transportation costs of the biomass is very low and resulting in a low price of the pyrolysis oil. High quality. All equipment and most connections can be tested in a factory acceptance test. At the time of the commissioning is shortened. Proven technology means less risk. We have been producing more than 175,000 tons of pyrolysis oil in 3 different sites. First plant Pyro, yes, the first plant, as Bert already told, costing a lot of effort to get it running. To give you an impression, in the first year of Pyro, we produced around 1,000 tons of pyrolysis oil, and now 1,000 tons of pyrolysis oil is produced in 2.5 weeks. Just to let you know how important it was that we have this first plant Pyro. So we have learned all the lessons of Pyro in our plants in Finland and in Sweden. No scale-up risk. We have done it before. The last bullet, bank loans are possible with export credit guarantee from Atradius. Also, the project in Sweden have been done with an Atradius guarantee. It's really reducing especially the interest rates of the customer. Standardization. The good thing about a standard is we hardly need any engineering. So no pre-feed, no feed, not long periods with engineering times. Everything is ready, especially when we talk about clean wood. If you go to more, let's say, exotic type of biomass, then especially the pre-treatment of the biomass is an important one. But if everything is, if you're looking to clean sawdust, then everything is done, and that's why we are ready for a full-scale commercial rollout. Short delivery times, within 18 months, you will have the first oil. Last bullet, we are completely standardized in EU design. We have now finalized the US design as well. We're not standardized there, but at the moment we're selling 1 or 2 plants to the US or Canada. We will also standardize in this one. The different applications of the pyrolysis oil. I go shortly through it because you know a lot, I suppose, and I would like to have some time for the last one, especially for the fractionation. Roughly speaking, you have 2 choices with fast pyrolysis bio oil. The first choice is to use the fast pyrolysis oil directly in existing infrastructure, as Pontus have mentioned as well. That's the first choice. You go to gasification, co-feeding to an FCC. That's the applications done by Pontus. Hydroprocessing, combustion and heating. Combustion heating is done in both Finland and in the Netherlands. You go to bulk chemicals, and that's for the direct use of the fast pyrolysis bio oil. The second choice is the fractionation of the pyrolysis oil, because you fractionate in the lignins and the sugars. The lignins can be again used for the gasification, co-feeding, hydroprocessing, combustion and heating, and bulk chemicals. And the sugars can be used for combustion and heating, bulk chemicals, and emulsification. There are different ways to if you look, for example, to sustainable aviation fuel. In sustainable aviation fuel, some people, like for example BTG Next, they are using the complete pyrolysis oil to go to SAF. Other companies, like for example Alder, they are fractionating the pyrolysis oil in 2 fractions, whereas the lignins are upgraded to SAF, and the sugars are used for other applications, like for example combustion and heating. Another application I like to mention is the gasification on an existing gasifier. It sounds a bit strange because people say, hey, why wouldn't you gasify the biomass directly? The big advantage of the gasification of a liquid is that you can use an existing gasifier, an existing oil resid gasifier. So we've done now several studies together with customers, and also have done a very large test using pyrolysis oil on existing gasifier. Around 700 tons of pyrolysis oil have been gasified on a gasifier in Europe, and that it was a big success. Very smooth operation, hardly any modification on the gasifier. So once again, it's a very interesting application due to the fact that you don't need to invest in a gasifier. Biorefinery 20. As mentioned in the beginning, we are not waiting for oil customers and biomass owners. We also develop our own projects. One of the examples is the Biorefinery 20, where we're going to fractionate the pyrolysis oil in different fractions. You can see here a picture of Empyro on the left, and you can see the fractionation, the 3D model of the fractionation plant. We are fractionating the pyrolysis oil in a 2-step conversion process to transform the different biomass resources into raw materials for biochemicals. The first step, you go to transform the biomass into a pyrolysis oil, and the second step is to fractionate the pyrolysis oil in 2 fractions, the pyrolytic lignin and the pyrolytic sugars. Now, the first step, as I mentioned, it's commercially proven. The TRL9, as also Pontus have explained, is a commercial applications. Around more than 175,000 tons of fast pyrolysis bio have been produced in 3 different production sites. The second step, liquid-to-liquid fractionation, has been proven at a pilot scale, 3 tons per day input by BTG, Biomass Technology Group. Now, we have now finalized the basic design for a 1.2 tons input per hour, a 10-fold scale-up fractionation plant, and we will locate it very close to the Empyro plant. In the future, the fractionation plant can easily be upgraded to a 3 tons per hour plant, matching the current production of a fast pyrolysis bio-oil unit. It makes a lot of sense to build these fractionation plants very close to an existing pyrolysis oil factory. This is an overview. You can see on the left wood residues going in. The first step is the pyrolysis step. We'll do it in the existing Pyro plant. Proven technology at TRL9. And then we have several streams. The first stream is the steam, and we're selling this steam to Nobian, the salt factory. And 40% of the pyrolysis oil is used for the fractionation. You can see a picture of the fractionation plant there. And 60% of the pyrolysis oil will be used by Friesland Campina, Royal Friesland Campina, in a boiler application. So what we're doing is in the fractionation unit, we're making the sugars, we're making the phenolics, and the lignin. The lignin is used by Kingspan, you may know the company, for insulation materials, and the sugars, the phenolics, and the fast pyrolysis bio-oil is used by Friesland Campina on its boiler. Now this fractionation unit is of course first of a kind plant. A lot of testing have been done, but it's a relatively simple process using existing and proven components. I like to use this slide to come back a bit on the question of the yield. There was a question, what is the yield of this process? What we are seeing in plants in Finland and Sweden is that if you use clean sawdust, the mass yield can go up to around 72% from biomass to oil. If you go to other types of biomass, typical yields are, let's say, 60%, 65%. Where we are with the status of the project, we will build this project via a sister company. The sister company name is Aurora, it's a sister company. And we built it at a scale of, as I said, 1.2 tons per hour next to the existing 3 tons per hour fast pyrolysis plant in Hengelo. Indication of the funding is around 15 million euro total project cost. We have long-term offtake agreements being negotiated for the pyrolytic lignin with insulation company, Kingspan, and with Friesland Campina for the combined pyrolysis oil and pyrolytic sugars, and a continuation of the heat supply to the Nobian salt factory. FID is expected the third quarter of 2025. Exciting project, and we once again hope to finalize it in the coming time. Summary. Lessons learned in Pyro and are implemented in Greenfield, Nordic and Pyrocell, and this resulted in a standard design, as I mentioned. Modularization leads to lower risks, shorter delivery times, short time on site, lower cost and high quality due to the high degree of standardization. Engineering efforts are very limited. Do not build the plants too large. Scaling by number is a good way to address the biomass availability and to lower the cost of the pyrolysis oil. Pyrolysis oil is a very interesting way to connect the biomass world to the industrial world, leading to energy, fuels and chemicals. And the last bullet, the Biorefinery 20 project is currently under development and FID is expected in the third quarter of 2025. Thanks for your attention.
Thank you.
Thank you, Gerhard. Very nice presentation, and also good news for the New Wave project, because the basis of our project is the fractionation. It's good to see that it will also be implemented on full scale or demonstrated on larger scale.
Yes.
Julio, can you see all the questions or not?
Yes, sure. There are several. One for Gerhard. How do you solve the problem of the fast pyrolysis bio-oil aging and instability?
Yeah, very good point. We heard this questions a lot. I will not speak on behalf of Pontus, but what we are seeing is that it is very stable. You can just store it if you would like for a month, because also in Pyrocell there's a storage tank in Gävle of around 8,000 tons. It stays there for quite a long time if needed. There's one thing is important, is to circulate the pyrolysis oil over the tank. That's a very important one. And typically pyrolysis oil does not like a very high temperature. So preferably, let's say room temperature, 20 degrees Celsius or lower. 30-35 degrees is not a problem, but don't do that too long. So that's typically a good rule. And once again, this is only for clean sawdust. If you go to other types of biomass, then you have to take a bit more care about especially phase separation. But we have developed that technology as well to remove a part of the water. And after doing that, what we are seeing is that the pyrolysis is very stable. You can easily store it for 1 or 2 years.
Okay, thank you. There were a few questions about the possibility to adapt the Pyrocell technology to be used for slow pyrolysis.
Okay.
Who will answer?
Yeah,
Pontus?
I don't know how that can be done.
No, same for me.
I mean, it's two different technologies, so I don't
Okay.
see how they could be combined.
No.
Okay.
But
Same
the
for
only
me.
thing is, of course, you can produce pyrolysis oil also via that kind of technology, slow pyrolysis, but it's completely different, I would say.
Correct. I agree.
Mhm.
Basically, it's not possible with the BTG bioliquids technology because the char is very finely distributed at very low contents in the sand circulation loop. So it would also be hard to remove it. And moreover, you need the char for the heat balance of the overall plant. So I don't think that's an option.
There is a question about the fractionation procedure to separate pyrolytic lignin and pyrolytic sugars. I know also, Bert, this is something that we are addressing in New Wave, but whoever wants to answer.
So what is the question?
Sorry, it's about the fractionation procedure. How does it work in general terms?
I think Bert can tell the best. Yes.
Well, we do a separation by liquid extraction, and the first step basically is it's an aqueous. It can be water or an aqueous solution. It's liquid extraction, and that causes the separation on functionality between the carbohydrates and the sugar fraction and the lignin. So it's really a separation on functionality, and we get a quite good separation between what's really the sugars and the lignin. And that's a little bit different from staged condensation, where you have separation on boiling point, and we prefer this route. So it's basically liquid extraction.
Thank you, Bert. There is another question. Is there any example of use of fast pyrolysis oil, either directly or after fractionation in any hydroprocessing unit of refineries via co-processing?
I think there are research examples in the sense that it's not done on commercial scale. The direct use, of course, for co-processing is the one Pontus was mentioning. That's co-refining, isn't it?
Yeah.
So that's the co-refining of pyrolysis oil, crude pyrolysis oil, untreated pyrolysis oil at the Preem refinery in Lisgil. I think I pronounced it wrongly, but that's
perfect.
Refinery. But there is no, it's not directly hydroprocessing. So that's not currently existing.
Okay. Another question. There are several questions. Some are very precise. What is the water content in percentage of your fast pyrolysis by oil? Do you encounter any problem with high water content in the oil?
According to the literature, the water content in the pyrolysis oil is around 25%. That's you can find in the literature, and I think that's a figure you can rely upon.
So it's close
because
to.
The question is if there's a problem with the water. The advantage of water in the pyrolysis oil, you can easily pump it, you can easily store it. So if you would remove a part of the water, it's more difficult to pump it. For a lot of applications, the water in the pyrolysis oil is not an issue. And if needed, then a part of the water can be removed, going from, let's say, 23% to 12, 13, 14%.
Yeah, and maybe in addition, roughly above 25%, you have this risk of phase separation. And once you get phase separation, of course, you have operational issues. So you want to be below that value, then it's an homogeneous or a virtually homogeneous liquid without phase separation, and then it's no problem.
But of course, as I said in my presentation, of course, we would like to see how can we reduce the content of water and metals. That's for sure, or oxygen is better to say.
Yes.
That could increase the value, heating value, and also that could be possible for us to reach new areas of end users as well. So we would like to go in that direction. But the thing is, well, the question is how.
Okay. There were a few questions. Someone I highlighted it before about the CO2 reduction. They were asking how it's possible to reach this level, especially if the char is burned for energy.
I think that's a bit too complicated to go through during this meeting.
Can I answer it a bit, maybe a bit more generic, if you allow me? Suppose
please.
that if you would burn the char and you make heat and you use this heat in a sustainable way, then it's also leading to CO2 reduction. If you would just, let's say, throw away the heat, yes, that's for sure. But part of the heat, at least that Pyrocell is also delivered to the neighbors. So that's also then a sustainable use. Another way to further reduce the CO2 is possible when you would have a CO2 abatement technology on the chimney. That's something else, but it could be added, and then you go to very, very interesting carbon reduction figures.
Okay. There's another question directed to you, Gerhard. So the lignin you use for insulation is in its polymeric structure or has already been depolymerized by the fractionation process?
I think that's a good question for Bert. Can you answer that one, please?
Well, basically, the fast pyrolysis itself is the depolymerization, and the fractionation is only the separation of the lignin and the sugar, and that's what you want. In general, the average molecular weight of the pyrolytic lignin is significantly lower than the original lignin. I think we are around an average molecular weight around 1,000 or something, somewhere in that range. So the depolymerization takes place in the fast pyrolysis process itself.
Great. There was a question about the cost of the fast pyrolysis plant in terms of capex. I don't know if this is something you can tell or refer to some standard figures.
I can refer standard figures, so Pontus doesn't even need to share anything. Don't be afraid, Pontus.
No problem.
No.
It's history. It's history.
It's history. That's why it's already quite a long time ago. Now, let's say I would like to use some generic figures. It's always a kind of dangerous, but we are quite transparent in this. If you would like to use a round figure, you can use a figure of around 30 million euros, 30 million. It's then including the dryer, including the commissioning, including the erection, including the transport of the modules. But it would also then suppose that you have clean biomass, so not a heavy, let's say, upgrading of the biomass.
Okay. There's another question. Why don't you perform the separation directly on the pyrolysis vapors at different temperatures instead of using liquid extraction?
Very good point. And it's more a logistical answer than a tactical answer. We strongly believe it's very important to bring the fast pyrolysis bio-oil plants to the biomass and go from the crude biomass to the crude oil on a decentral location. And then you have two choices. You could fractionate at the plant itself. That's the first logical choice in the beginning. But you can also imagine that you do the fractionation on another location on a larger scale. So what you're doing is you bring the fast pyrolysis bio-oil from different locations to a central location and do the fractionation there. So that's the more, and if we look to, please, Bert, yeah?
Yeah, I think the question is maybe even a little bit different, why we don't use, let's say, kind of staged condensation. Probably we answered it before. We prefer liquid extraction because separation on functionality, and you can really have a very good separation between the carbohydrates and the lignin, and that's what you really would like to achieve. If you do it, as mentioned here, in the pyrolysis vapors at different temperatures, that's what we would call the stage condensation. I know there are quite some companies, institutes, universities working on that part. But the separation is not very good because it's a separation on temperature, and we would like on boiling point, and we would really like to see the separation on functionality, and that's what we believe. This is a better approach than do it on temperature, because then still you have the lignins and the sugars in all the fractions. So it's not the fractionation we have in mind. And what we also observe, both for the sugar application as well as for lignin application, it's good to have a very good separation there. And that really helps for the quality of the product. So in that sense, we are not in favor of stage condensation, and we did this on purpose.
Okay. I don't know if Pontus wants to add something, or we can go to the next question.
Please continue.
Yeah, which is connected to the previous, one of the previous one. What is the minimum capacity of fast pyrolysis for good efficiency or good economy of scale for this kind of technology?
For the fast pyrolysis, you say, or the fractionation? Fast pyrolysis?
No, for the fast pyrolysis plant.
Okay, yeah, good point. We have chosen for 5 tons per hour of biomass. What we are seeing is that typically is sufficient to have a sustainable and abundant supply of biomass. If you will go larger, I'm not saying it's not possible, but if you go larger, then the transportation of biomass starts to be an issue. And that's why we believe it's important not to build too large. If there will be a larger requirement, especially in the US, you see some huge plants, then we would deliver multiple units on one location. So then we combine, and then we are delivering 4 different CPUs for one project.
Okay. Answer to that. Maybe I can add another question from my side that, I want to leave it open for the 3 of you about the feedstock. We know that supplying enough quantity of sustainable biomass is crucial, especially if we think about the upscaling of production of sustainable aviation fuel, which is a hot topic today. There are concerns about the capacity of new plants, that it's going to be hard. Do you think fast pyrolysis by oil could be a solution for production of SAF? Do you see a lot of unused biomass feedstock?
Good point. There's a distinction between, let's say, the agro residues and the forest residues. And I believe Scandinavia is a perfect example where a lot of biomass from the forest is used in a very sustainable way. So I would say that residues in Scandinavia hardly exist from, let's say, from sawmills. There is a way of the forest residues coming from the forest. That can always be an issue to more logistically speaking, how to get it from the forest. A lot of initiatives I'm seeing now, both in Europe, but also in Canada and in the US, is to pay companies to get forest residues from the forest, because it's especially for forest fires, it starts to be really an issue as we are seeing. If you talk about the agro residues, I love this a lot. At the other hand, the prices of agro residues are not that low yet. Farmers, they have to make a choice, and a kind of the nitrogen value of the agro residues is typically speaking 40 euros per ton, 50 euros per ton. That's the lowest level. And if it will be lower, then the farmers will leave it on the land as a kind of fertilizer. And I think it's a perfect and good choice. The disadvantage of agro residues is seasonal, so there's quite some collection costs. So I don't believe there's a kind of scarcity, but there is still a lot available, but it's more depending on economics, if you can have it from the land in a good way.
Yeah, and I can also add a little about the the supply of a biomass. And for instance, only Sweden regarding sawdust, and that supply should be around 5.5 million tons annually, of which you could make at least 1.5 million tons of pyrolysis oil. And there is much more biomass, I mean, in theory, much more, depending on feedstock, of course. I'm just referring to sawdust. You have much more to utilize if you can or are willing to. Just a comment.
Yeah, maybe just to add to the speakers, if you go to SAF, typically you need a very large scale, and in that sense, pyrolysis oil could be a very nice intermediate because you can do it where the biomass at a somewhat smaller scale or at a decentralized scale, and bring it to a centralized upgrading. And to a certain extent, I think also the Pyrocell value chain is a good example of that, where you produce the pyrolysis oil at one location and bring it to a much larger existing refinery elsewhere in Sweden. And that could also solve a problem of logistics. You don't need to bring all the biomass at large scale to a single location. And it's a little bit a combination of centralized and decentralized in an optimal way. And I think in that sense, it's also a good bridge between existing biomass utilization and chemical industry.
Thank you. There are a few other questions, then we are approaching the end of our webinar. A question for Gerhard: what type of wood biomass is used for the fast pyrolysis by oil production? Has the plant ever processed a mixture or blend of woody biomasses?
Good point. So blending of biomass is typically relatively complicated. So that's typically what we're not recommending. You could run campaigns. Then you can say, okay, a campaign of 1 month for biomass type A, and then 1 month for biomass type B. If you try to, you can imagine, so suppose that you would have really exact sawdust with the same configuration of the size of the materials that it may work, but typically speaking, it's very difficult to mix solids. You could mix them if they're first pelletized, but typically not advised.
And in addition, maybe I think a blend of woody biomass could work. If you would consider blending wood and agro residues, we won't advise that, because I think that there will be some negative impacts from the agro residues, and which also affect the conversion of the woody biomass. That's something we would like to avoid, I guess.
Yeah.
Okay, thank you very much. There were still a few questions left, but we have come to the conclusion of our webinar. For those interested in submitting more questions, I encourage you to send an email to the email I put in the chat, so info@newwaveproject.eu. And then, of course, to discover the future developments and results stemming from a New Wave project, I encourage you to check our website, where we will post in the next months new interesting results. And again, as I said at the beginning, the recording of this webinar will be available very soon, as well as the presentations that you shared. So I thank the presenters of today, Gerhard, Pontus, and Bert. Thank you for insights, and see you in another webinar.
Thank you.
Thank you for organizing.
Thank you.
Thank you. Okay, bye.
Bye-bye.
Okay. Bye-bye.